So today we're going to be working on CodeCheck Python Exercises, the assignment Nested Branches and Booleans. And I do have to make a confession. I tried to make this stream just a few minutes ago, and it took me almost 28 minutes to complete this assignment because I got stuck on one of the problems. So I'll tell you when I get to that problem. If you're watching on YouTube, I'll put a link if you care to watch my failed attempt and watch me squirm when I try one of the problems. But I'll try to point out some of the things that went wrong and try to guide you for how to approach that problem so you don't get stuck in the same way that I did. Let's go full screen. Rearrange the lines of code below to produce a program fragment that reads user input and prints whether a time such as 9 a.m. is in the morning, afternoon, or evening. Prompt the user for the hour before the suffix. Press start. So first we need to take some input from the user, and they say prompt the user for the hour before the suffix. So in terms of which order we put these, hour and suffix, we want to make sure we do the hour before the suffix. Then we want to see whether it's in the morning, afternoon, or evening. So we see if the suffix is PM, what does that mean? So morning, could that be PM? No. Morning can't be PM. Evening, could that be PM? Yes. Afternoon, could that be PM? Yes. So both afternoon and evening could potentially be in PM. Otherwise, morning. So if it's not PM, it should be AM, which means it should be morning. And the last thing we'll do is print the output. So where does this else if hour less than 6? So less than 6 is going to be the threshold for afternoon versus evening. That's kind of subjective. They've just chosen this 6 p.m. as their definition of when evening starts at 6 p.m. whereas if it's before 6 p.m. it's the afternoon. So if hour is less than 6 p.m. inside the PM branch, we're going to create a new branch, and so we have to tab over then time is afternoon, and otherwise if the hour is greater than or equal to 6, then evening, and that has to be tabbed over as well. In this activity, you will trace through an example of a misaligned else statement. The code is supposed to determine whether a time such as 9 a.m. is in the morning, afternoon, or evening. For each input, click on the conditions of the if statement that are tested and then on the statement that is executed, which may be another if statement. Be sure to trace what actually happens even though the result will not be correct. So they're saying this code is wrong, but want you to trace it, so follow the execution and say what the values of different variables are along the way. So let's click start. So they're just shifting through 4 lines. So hour, suffix, time, and then if suffix equals PM. So hour equals input, the user input 3, suffix equals input, the user input PM, so 3 PM. Time equals morning is hard-coded. If suffix equals PM, so suffix is PM, does PM equals PM? Yes. So we're going to go into this branch and go to this if statement. And then if hour is less than 6, hour is 3, 3 is less than 6, that's true. That means we're going to go into this branch, set the time equals to afternoon. Now a bunch of stuff just happened. We left this if statement and we do nothing after that. We left that bigger if statement and we do nothing. We don't hit the else because we hit the if. So we skip over the else and we go down to print good time. So we did good afternoon. Now new table row is a new input from the user. Now the user is saying 9 as the hour. They're saying PM as the suffix. Then time equals morning is hard-coded. If suffix equals PM. PM is the suffix, yes. So we're going to go in here. If hour less than 6. Is 9 less than 6? No, 9 is greater than 6. It's not less than 6. It's in the category of greater than or equal to because it's greater. So we're going to say no and not enter that. So we're going to say finish this outer if statement, nothing else to do. Not going to hit the else, so we're going to go down to print good time. good morning, go back around, take 9 a.m. morning. If suffix equals PM, does AM equals PM? No, so we hit the else, set the time equal to evening, and print good evening. Fix the code from the preceding problem so that the correct greeting is produced. Be sure to properly align the if and else statements. Time equals morning, hour equals something. Okay, so we're hard coding the time to be morning. So by default, our answer is going to be morning. And we're going to, at the end, we'll print good greeting. I'll hit start. Good greeting. So good morning in this case by default. Now, if the suffix is PM, now we could be in the non-morning category. So again, we can just drag in time as afternoon, which is before evening. So afternoon, then evening. So here we're just setting it to afternoon, immediately changing it to evening. So instead, we want to say if the time is less than 6, then we are in the afternoon. So we need to tab this over. So if PM and if hour less than 6, then set time to afternoon. Otherwise, so else, then set the time to evening. Finally, print good greeting. And suffix, we need to grab the suffix from user input before we start this if-else chain. 4. Okay, this is the one that I got stuck on. So this, let me explain this. Complete the program that reads the times for the two events, such as 3 p.m. and 11 a.m. Determine whether the first event occurs before the second event at the same time or after the second event. Print before, same, or after. So we have time 1, suffix 1. So like time 1 is 9 a.m. 9, and then suffix 1, a.m. Time 2, 12 p.m. Time 2 is 12, suffix 2 is PM. So we need to, based on the times and the suffixes, we need to decide whether time 1 happens before or after time 2 or at the same time. And of course it shows you my solution here, but I'm going to reset this so that I can talk you through it. So I got a little bit confused just thinking through, as this problem is intended to do, is to sort of trip you up and make you not sure which thing to put first. So if I were just writing this code straight, maybe I would be able to reason through the logic step by step, but they've actually given me a template in which I have to fit. And so I have to think about the problem a little bit differently. So we see this big if and nested if statement. So if, and there's a branch, and then there's an if, and then an else. If that doesn't happen, then another if. So we have like 3 layers of ifs. And then this one we just have an else and then one more layer of if. So a way that I didn't think about this originally that might be good to break down the problem before getting started is we know we have to compare the suffixes and the times. And there's a combination of like if the suffixes are the same or they're different, or the times, one time is less than the other time, or that time is the same, then that determines the answer. And it's easy to reason through the logic step by step, but think about from the previous problems, what's the easiest way to kind of like split this into the simplest possible categories. So dealing with the times first or dealing with the suffixes first. So if you deal with the times first, then you have to go in and handle not only are the times, which time is bigger, are they equal, but then you have to go and deal with the suffixes. With the suffixes first, then you can say, well, if the suffixes are the same, then I only have to worry about the time aspect. But if the suffixes are different, I automatically get to choose the one that's later. So if they're different, that means one is AM and one is PM. So either time 2 is AM and time 1 is PM, or the reverse. So that category is actually simpler. So try to think about when you're fitting into this structure here, which is likely going to be this else case versus which is going to be the outer if. So the else case is going to be the simpler one. that's going to be the one where, okay, in this entire branch, and I have an advantage because I worked through this and tried a couple of failed approaches, but this entire branch is going to be when 1 is AM and 1 is PM. So that means they're different. The suffixes are different. So that is your first part to break down the problem. Suffix 1 is not equal to suffix 2. And then this is what this entire branch is. Sorry, so this entire branch meaning the else here. So this first entire branch is going to be the opposite of that. So when they are equal. So the first branch is when they are equal. We'll deal with that in a second. The other entire branch is if they are not equal. So now 1 is AM is 1 is PM. If time 1 now, or suffix 1 is AM, then we know that the first time occurs before the second time, because suffix 1 is AM and suffix 2 is PM. AM is before PM, time 1 is before. So we fill before. Then the opposite is after. So this means that suffix 2 is PM, PM occurs after AM. Okay, we've dealt with that entire branch. Now the other branch is when suffix 1 is equal to suffix 2, so they're both AM or they're both PM. Now we just have to worry about the times and whether the times are 1 is bigger and 1 is smaller, which one is which, and then whether they're equal. So if they are equal, that would be the simplest case. That's why this is a small, it's just if. It's just an if. If the simplest case is they're equal, so if time 1 equals time 2, then the suffix is the same, time is the same, the whole thing is going to be the same. Now in the other case, the suffixes are the same, so we're both AM or we're both PM, but now one of the times is bigger and one of them is smaller. If time 1 is bigger than time 2, then we know that time 1 must be after time 2. And otherwise, we know that they can't be the same because we already handled that. So now we know that time 2 is bigger in the else case, which means we print before. Because time 2 is bigger, meaning time 1 is before time 2. And we pass all the tests now. So just want to remind you that did take me a couple times working through it and picking the wrong initial if statement to choose. Even though the logic is simple, fitting into this format can be challenging. So just be mindful that if you get tripped up by this or you're not following the logic, it's okay. Keep working at it and you will figure it out. Last one. Simplify the following logical conditions assuming that n contains an integer and b contains a Boolean value. So b is a variable here that is going to be a Boolean value, so that's either true or false, whereas n is an integer, so like a number. Let's start. N less than 5 or n equals to 5. So that's the same as saying n is less than or equal to 5. N less than or equal to 5. And whether I have spaces here doesn't really matter. N less than or equal to 5 and n not equal to 5. So we're saying less than or equal and not equal. We're basically just saying less than but not the equal. So the equal was included here but excluded by the not equal, so we just go down to n less than 5. N less than or equal to 5 and n greater than or equal to 5. So we're overlapping less than or equal to and greater than or equal to. The only overlap there is equal to, because you can't be less than and greater than at the same time. So those two are eliminated when we have an and, but each of those contains equals. So n equals 5 and n equals 5 is the same as n equals 5. n less than or equal to 5 or n greater than or equal to 5, that just includes everything. N is less than 5 or equal to 5, or n is greater than 5 or n is equal to 5. So that is true. Capital T is how true is spelled in Python. Not n less than or equal to 5 means the opposite of less than or equal to 5. It's not less than, not equal to, meaning it must be greater than, and greater than 5. Not B, the nots cancel out and you just have B itself. B equal true, you would get, just simplifies to B because B is a Boolean. So if B is true, then true equals true is true. If B is false, then false equals true is false. So either way, it's just B. B equals false is the same as saying not B, which is not valid syntax in Python, so it actually needs to be not B like that. So not B. If B is false, then not B would be true, and true equals false would be false. If B is true, then not B would be false, and I might have just said the same thing twice. If B is true, then yeah, okay, it just submitted for me. It's saying this exact thing. If B is false, not B and B equals false are both true. So think about that for a second. B is false, so false equals false. That is true. And B being false means not be true. If B is true, not B and B equals false are both false. So just read through and think about that if that's not clear. But B equals true is always going to simplify to B, and B equals false is always going to simplify to not B.